Hi, this is Sudeep Panchanda from Quite Easily Done. Today we'll be doing another Beginners project, and this time we'll be using a motion detector sensor to create an automated light which would switch on if there is a motion detected in the room, and if there is no motion the light would switch off. A very good use case to save electricity in our homes. What we will be using is this very commonly available PIR motion sensors. It's got three pins, the positive and the negative for the power supply, and one is a digital output. If there is a motion detected, it gives a digital 1 output, and if there is no motion detected, it gives a digital low, a 0 output. It's got two potentiometers over here. If we put the motion sensor upside down, the one on the left is the sensitivity, which basically talks of is used to put the threshold of how sensitive the motion detector is, how big a motion is required to trigger a logic high. And the other one is a delay circuit, which says how long will the logic 1 remain if a motion is detected. So in the case where we're using a motion detector to switch on the light in a room, we don't want that if I come up and sit on this chair and I'm not making big motions for next 1 minute, the light should get switched off, because not every time when I'm in the room would I be making big motions for the motion detector to be able to sense. What we would do is we would set the timer around 1 or 2 minutes. So whenever it detects a motion, the next 1 minute the light would be on, and if it does not detect a motion for the next 1 minute, it would switch off the light. So let's have a close look at the sensor first, and then try and put this entire circuitry into a switchboard. So like always, we will be using a relay board to read the digital signal from the sensor and switch on our electrical appliance. Okay, let's start with having a closer look at the sensor first. So this PIR motion sensor is there are three pins. The left is the ground, the right is the positive VCC, which we would be giving as plus 5 volts. So that's the red one as the positive supply, the black as the negative supply. In center we have is the digital output, which would give us logic 1 when it detects a motion, and the logic 0 when it does not detect one. If we flip it over, the left is the potentiometer, which defines the sensitivity. The right potentiometer is what we defined was the delay. So if a motion is detected, the output is going to be remaining high for a while, and that how long is the output remaining as 1, which is defined by the potentiometer over here. Depending on the model that you're using, this delay can be around 0.3 seconds to 5 seconds, I guess. So yeah, so now that's the sensor, and then we have is our standard relay board. We would be using the plus 5 volt supply on the relay board to power up the sensor. We would be giving it the digital output from the sensor into the input pin over here, and we would be using a 12 volt adapter to give in the supply to the relay board over here. So this I'm using is the cheap and small compact 12 volt adapter that we find, which is used for powering up an LED strip. So all of this I'm going to connect it and put it into the switchboard. That's the reason why I'm trying to use these smaller components. So let's look at the assembling process. So I have opened up the switchboard of my room, and I see a lot of wires, so I'll be explaining that in a minute. But before that, just a word of caution. Just in case you don't know about electricity, I would suggest you take professional help. And in case you're a minor, please ensure you have an elder's supervision, because playing up with electrical wires with 220 volts running in it can be dangerous. So we know a 220 volt AC has a live and a neutral wire. All the black over here are the neutral in my switchboard, which is connected to all the appliances, the lights and the fans. We have a live wire running in, the red ones coming in over here. You can see in the tester, this is a live wire. Do not touch that. And the yellow ones are the ones that go to the electrical appliances over here. So when I switch, so right now if I look at this, it's not live, and I switch on the I see the tester glowing, which says the switch is on. Okay, what I intend to do is I'm going to leave the neutral as it is. I'm not going to use both the polarities on my relay board. I'll feed it to this, the right one over here on the relay board is supposed to be neutral, and I'm going to not connect anything to it. But the red live, I'm going to connect over here, and to my NO, I'm going to connect the yellow appliance one. So now the relay is actually going to do what the switch is doing on the switchboard. And then obviously the rest I've explained. Let me do the connections first and then show you the thing in action. So I've now done all the connections. I have my 12 volts adapter connected to the ground and the live wire over here. So now the output I get into the relay board as the 12 volts from the adapter. What I've done is I've given the live wire over here into the relay board also. Into the relay board over here. The output of the relay board, which is when the output is 1, the NO1, goes back to the yellow wires, the appliances. So when the relay gets triggered, the live gets connected to the appliance and the circuit is complete, the appliance would get switched on. For now I have this switch in parallel to the physical switch that I have. So what will happen is, if I have this switch on, no matter if the motion is there or not there, the light is always going to be on. If I keep the switch off, the light would be on only when the motion detector detects a 1, is giving a 1 to the relay board. So and the rest of the circuit is the same as I had mentioned before. The power supply to the relays, to the sensor, and the output of the sensor going to the relay board. So I'm just going to pack up the switchboard and show you the entire circuitry into motion, the working thing. So now that we have the entire circuitry assembled into the switchboard, a motion detector light should work the way we expect it to. Right now, if you see, the switch on the switchboard is switched on, which means I'm manually overriding what my circuit is supposed to be doing, like this, all on in spite of what my motion detector sensor is saying. For demonstration purposes, the timing on the motion detector has been reduced a lot, which means it really needs continuous motion for it to be remaining on. So the timer is almost close to 0.2 seconds. If it does not detect anything in the 0.2 second, it's going to switch off the light, which is not what we will be doing practically. The time is going to be around a minute or two. So in order to demonstrate the entire functionality, what I'm going to do is I'm going to switch off that switch on the switchboard so that the motion detector center takes up the light control. I'm going to move out of the room to simulate a no motion, and then I'm going to re-enter into the room after like half a second to show that how the motion detector, when it detects the motion, it switches on the light for me. So there you saw that when I moved out of the room, the light were switched off, and when I re-entered into the room, the lights were automatically switched on. Now the reason why I'm switching on the light, the switch on the switchboard, is because, as I said, the time has been set very low. So even if while I'm talking onto the microphone and having the motions very low, it will switch off the light. So that's the automated lighting using the motion detector, quite easily done. Please write down in the comment section any questions that you have, any suggestions, any feedback. We would really love to hear from you and answer your queries. Thank you so much.